Hi students, I am Ranjit Raj. Welcome to my channel Math Learning Tutorial. So students, in previous video we have learnt about polynomials and types of polynomials, zeros of polynomials and remainder theorem, and also we solved problems on those concepts. So children, in this video we are going to learn about factor theorem, okay na, and factorization. Okay, so what is the factor theorem? Okay, so children, suppose first of all, what is factor? Suppose you with example I'll explain children. Suppose 6 is there. If 6 can be written as 2 into 3, okay, 6 can be written as 2 into 3. Here 2 is factor of 6, also 3 is factor of 6. Okay now, 2 is the factor of 6, 3 also factor of 6. If you divide 6 with 2 or 3, your remainders will be 0. So whenever we are dividing one number with another number, okay, if our remainder is 0, then with whatever we are dividing, those are said to be factors. Okay now. So children, here factor theorem. So let's see what is the factor theorem in the polynomials. Okay. So children, let us assume P of x is a polynomial. Okay, P of x is a polynomial of degree n greater than or equal to 1. Okay, so this is the polynomial, and a is a real number. A is a real number, and children, then okay, x minus a. Okay, here the thing is, children, P of x is a polynomial of degree n greater than or equal to 1, and a is a real number, and here it is divisible by x minus a. It's divisible by linear polynomial x minus a. Okay, so children, P of x is a polynomial of degree n greater than or equal to 1, a is a real number. It's divisible by linear polynomial x minus a. Means this polynomial P of x is divisible by linear polynomial x minus a. So children, here there are two statements in this theorem. So first statement is, so x minus a is factor. Okay, x minus a is the factor of P of x. Okay, x minus a is the factor of P of x if P of a is equal to 0. It means, children, remainder. Okay, if a remainder P of a is equal to 0, then x minus a is a factor of P of x. Okay now, second statement is its converse. So converse means a reverse statement, children. Okay, so if x minus a is, so second statement is, if x minus a is factor of P of x, then P of a is equal to 0. Then remainder P of a is equal to 0. So children, very simple. X minus a is the factor of P of x. Okay, when if P of a is equal to 0, suppose they gave remainder is 0, then the divisor is called factor. Okay, so suppose in question they gave x minus a is factor. So they mentioned already x minus a is factor. So then automatically we can tell that its remainder P of a is equal to 0. Okay, so children, let's see its proof. Okay, so now I will prove the first statement. X minus a is the factor of P of x if P of a is equal to 0. So children, let's P of x is divided by x minus a, and its quotient is some q of x. Remainder r is equal to r is nothing but here P of a. Now apply division algorithm. Dividend is equal to divisor into quotient plus remainder. So P of x is equal to x minus a into q of x plus remainder. So that's P of a here. Okay now, so here in the question they gave P of a is equal to 0. Then P of x can be written as x minus a into q of x plus 0. Okay, so here P of x can be written as x minus a into q of x. So children, here polynomial. So given polynomial, so we are writing as x minus a into q of x. So it's product of these two things, children, x minus a and q of x. So then automatically we can tell that x minus a is the factor of p of x. Okay, now therefore x minus a is factor of p of x. Okay, hence first condition proved, first statement proved. Now let's see second proof, children, second statement. If x minus a is the factor of p of x, here already they gave x minus a is the factor of p of x. Okay, now then p of x can be written as x minus a into q of x. So already they mentioned it's a factor. Okay, so now we need to prove remainder is 0. So children, so apply remainder theorem. What is the remainder theorem? If p of x is divided by x minus a, then the remainder is p of a. Okay, now so children, here x minus a is factored. So we are dividing this polynomial p of x with x minus a. So then x minus a is equal to 0, then x is equal to a. So by remainders theorem, okay, so by remainders theorem, just instead of x you take a, children. So p of a is equal to a minus a, okay, na? A minus a into q of x. So children, p of a is equal to a minus a value is 0, 0 into q of x. So 0 into anything is 0 only, no? So what we got, p of a as 0. Means here they mentioned x minus a is factor, then automatically remainder will be 0, p of a is equal to 0. Okay, na? So children, once again I will repeat the theorem. If p of x is a polynomial of degree n greater than or equal to 1 and it's divided by x minus a. Okay, so two statements. First statement, x minus a is a factor if p of a is equal to 0. If remainder is 0, x minus a is factor. Second statement, if x minus a is factor, then remainder p of a is equal to 0. That's it. Okay, now student, now let's see what is the factorization. So factorization of numbers is nothing but, children, so expressing the given number as product of its factors is called factorization. So suppose one example, you take 12, 2 into 2 square into 3, that's the factorization of 12. Okay, so 12 can be written as 2 into 2 into 3, so or 2 square into 3. So 12 factorization is 2 square into 3. But if they give polynomials, quadratic polynomials especially, how to factorize? Okay, now so children, here see, if they give quadratic polynomials which are in the form of ax square plus bx plus c, how to factorize this? So children, I will explain you with one example. Okay, now so first we have to take the product of first term and last term. Okay, now we have to take the product of first term and last term. So what is that? Ax square into c, means ac x square. So this is the first step. So children, next step, we have to take the factors of ac x square in such a way, means pair of factors, two factors we have to take in such a way, either sum or difference of that factor should be equal to the middle term. Okay, so then we will use the distributive property and then we will factorize the given polynomial. Okay, now children, let's see one example. Suppose x square, so factorize x square plus 5x plus 6. So children, this is polynomial, right? And what I am telling you, step 1, take the product of first term and last term. First term is x square, last term is 6. So what is the product of 6 and x square? 6x square. Now children, we need to take the factors of 6x square in such a way, either sum or difference. Either sum or difference should be equal to the middle term of this quadratic expression, quadratic polynomial. Okay, so children, 6 factors, 2 3s are 6, 1 6 are 6. Suppose if you take 1 and 6, so children, take the sum and difference. 1 plus 6 is 7. Difference is 6 minus 1 is 5. 1 minus 6 is negative 5. So negative 5. Okay, 1 minus 6 is negative 5. 6 minus 1 is 5. Okay. Children, but if we take 6 and minus 1, if you multiply this, what we will get? 6 into negative 1, negative 6. But what we should get, but if you multiply them, you have to get this number only. Okay. So now, let's see for another pair. 2 3s are 6 children. 2 3s are 6. Okay. So 2 plus 3 is what? 5. No? And here what is the middle term? 5. So here just put x. Okay. And take this expression x square plus. Now split the middle term with help of these factors. So x square plus 2x plus 3x plus 6. Okay now children, let's see first two terms. X square 2x. X square is nothing but x into x plus 2 into x. X is common. So a into b plus a into c, there means what we will do? A of b plus c. So what is this distributive property children? A into b plus a into c, there means we will write it as a of b plus c. So in the same way here we can take x common. So x into x is x square plus x into 2 is 2x. Okay now. Children, now let's see third term and fourth term. 3x plus 6 is there. 3 into x, 3x, 3 to the 6, right? So we can take 3 common, 3 of x plus 2. And one is very important thing children. Whatever we are getting in first brackets, it's inside of the first bracket, same thing we must get again inside of second brackets also. So this is the important rule. These two things must equal always. Okay. Now children, x plus 2 again same. We are using distributive property now. A into b plus, okay, here x plus 2 only same, no? B into a plus c into a. So you can write a of b plus c. X plus 2 same. Just you take it common. Okay. Now children, what is left if you take x plus 2 outside? X and 3, no? So that x plus 3 we will write here. And children, in this way we will factorize the given polynomials, especially quadratic polynomials. So children, in this way we will factorize the polynomials. Now let's see problem number 1 in exercise 2.4. Determine which of the following polynomials has x plus 1 as factor. Okay. So children, we have to use the factor theorem. So if p of a is 0, it means if remainder is 0, then x minus a is called a factor. Okay now. So children, here instead of x minus a, x plus 1 is there. Okay. So we have to find the remainders children. If remainders are 0, then the divisors are factors. Okay now. So let's see first problem in this first bit. Okay. So take it as p of x children. P of x is equal x cube minus x squared minus x plus 1. And we are dividing it with some g of x plus 1. Okay, so x plus 1 is equal to 0. That implies x is equal to negative 1. Now children, find the remainder, means p of minus 1, that is equal to minus 1 cube minus of minus 1 square minus of minus 1 plus 1. So negative 1 cube is negative 1. So minus of minus 1 square is what? Minus 1 into minus 1 plus 1. Minus into minus plus 1. So children, negative 1 minus into plus. Here nothing there means plus children. Minus into plus is minus. Minus 1 plus 1 and plus 1. So minus 1. So children, when two minus symbols are there, it means when two negative numbers are there, we have to add and take the negative symbol. In between them, into is not there. Please remember. Some students immediately, if 2 minus there means they will say plus. That's big mistake. Minus 1 is minus 2. Okay, so minus 2 plus 1 is plus 2. Minus 2 plus 2 is 0. So children, here we got a remainder p of minus 1. So I wrote a short form. REMS children, please remainder. So remainder p of minus 1 is equal to 0. Therefore, x plus 1 is factor. Okay, therefore x plus 1 is factor. Now children, let's see second problem. Okay now. So take that polynomial as p of x. So p of x is equal to x power 4 minus x cube plus x squared minus x plus 1. So we are dividing it with polynomial, linear polynomial x plus 1. So where x plus 1 is equal to 0, x is equal to negative 1. So now we need to find the remainder, that is p of negative 1 minus 1 to the power of 4 plus minus of minus 1 power 3 plus minus 1 square minus of minus 1 plus 1. Okay, so just replace x with negative 1, children. Negative 1 to the power of 4 minus negative 1 to the power of 3 plus negative 1 to the power of 2 minus of negative 1 plus 1. So minus 1 to the power of 4 plus 1. So minus of minus 1 cube is minus 1 plus minus 1 square is plus 1. So minus into minus is plus and plus 1. Now children, see 1 minus into minus plus, so 1 plus 1 plus 1 plus 1 plus 1. So last two ones as previously, this is 1 minus into minus plus 1, 1 as previously. Here remainder is 5, children. Okay, so remainder p of minus 1 is not equal to 0. We got non-zero remainder. If remainder 0, then only that particular divisor is called factor according to the factor theorem. So children, here therefore x plus 1 is not a factor of p of x. Okay, so children, in this way we will solve this problem. Children, let's see problem number 3. So p of x is equal to x power 4 plus 2x cube plus 2x square plus x plus 1. So we are dividing with x plus 1, so let it be g of x. Okay, and x plus 1 is equal to 0, x is equal to negative 1. So remainder is p of minus 1. So that we need to find minus 1 power 4 plus 2 into minus 1 cube plus 2 into minus 1 square plus of minus 1 plus 1. So minus 1 to the power of 4 is plus 1 plus 2 into negative 1 plus 2 into positive 1 plus into minus is minus plus 1. So now children, see 1 plus 2 into minus 1 is minus 2. So children, actually plus into minus is minus, so overall it's minus 2. So plus 2 ones are 2, it's plus 2. So minus 1 again plus 1. So children, if you see minus 2 plus 2 cancel, plus 1 minus 1 cancel, but 1 is left, children. Okay, so 1 is left. Here remainder, okay, so remainder p of minus 1. P of minus 1 is 1, it's like remainder is not equal to 0, therefore x plus 1 is not a factor, okay, not a factor of p of x. Okay children, now let's see fourth problem. Okay, so take given polynomial as p of x is equal x cube minus x squared minus of 3 minus root 3 of x plus root 3. Now children, we are dividing it with x plus 1, which is equal to g of x. So g of x, x plus 1 is equal to 0. So that implies x is equal to negative 1. So now remainder we need to find, children, p of negative 1 minus 1 cube minus of minus 1 square. So children, whenever I am taking negative instead of x, so after minus symbol negative, if I wanted to take negative number, then I am taking in bracket. Please observe this. So to avoid the confusion. Okay now. So next minus 3 minus root 3 of minus 1 plus root 3. Right children? So negative 1 cube is negative 1. So minus 1 square is what? Plus 1 only. Now children, minus, so this here it is minus symbol, children. Again here minus is there. So minus into minus we can write plus. So 3 minus root 3 plus root 3. Okay now? So here see minus 1. So minus into plus is minus 1 only. Plus 3. Okay. Minus root 3 plus root 3. So children, minus root 3 plus root 3 get cancelled. Minus 1 is minus 2. Minus 2 plus 3 we will get. 3 minus 2 is nothing but 1 only. So children, here also we got remainder as non-zero. Okay, so if we get remainder 0, then divisor is factor. But children, here we got non-zero factor. So therefore, x plus 1 is not a factor of p of x. Okay now. So children, in this way we will solve this problem. Okay. So children, I think you understood well. If you have any doubts, please put in the comment section. Okay, so children, you can also find previous videos in playlist. Okay, and children, please subscribe my channel and share my channel. Thank you for watching. Bye.